Alright, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So today we're going to continue on last topic in research methodology, which is inferential statistics. This is an introduction to inferential statistics, right? So I think this topic is going to be very fast since you already learned this topic on STA 220, right? So the purpose of hypothesis testing is to permit generalization from a sample to population which it came. So generally the goal is to disprove the null hypothesis based on the observed evidence data obtained from the sample. So we do inferential statistic to test our hypothesis to prove whether the null hypothesis is wrong, right? Due to the element of uncertainty involved, the level of error must be stated. Right, the level of error means type 1 error, which is our level of significance, should be measured first, to be calculated first, before we start doing our hypothesis testing. Right, so normally in social research, there are stated alpha equal to 0.05, but for clinical trial, any clinical or science based evidence research, um, we should calculate the type 1 error, the probability of type 1 error, which is alpha level of significance, before we start doing our hypothesis testing. Right, so in other words, the alpha value dictates that the possibility of making wrong conclusion is at most equal to alpha. Right, so normally when you do statistical testing in using apa nama inferential statistics, right? Either you are using in independent sample t-test or paired sample t-test, Way Anova, linear regression. So you always depend on p-value, right? The p-value, the benchmark for the p-value is our type 1 error, right? Type 1 error is our alpha lah. So the example of hypothesis testing, which is a test of normality, right? For if you still remember, you have several tests of normality you have learned in STA 220. One of the tests is Kolmogorov-Smirnov and Sapir-Wig, right? We want to test the quantitative variable, whether it is normally distributed or not normally distributed, right? So we usually test normality distribution on continuous quantitative variable, right? So for categorical variable such as nominal scale and ordinal scale, we don't need to test normality because it will not be normal, right? So the hypothesis for test of normality, right? The null hypothesis, there is no departure from normality, means that there is a normal distribution, right? Alternative hypothesis is the distribution is not normal, right? So the procedure is to compute a Kolmogorov-Smirnov statistics. So if you are using SPSS, it is actually a Liliford Kolmogorov-Smirnov method. It's an modified method of the original Kolmogorov-Smirnov. When the p-value for Kolmogorov-Smirnov is more than 0.05, our alpha, right, then the distribution is stated as normal because we fail to reject the null hypothesis. If the p-value is less than 0.05 or significant level, then we're going to reject null hypothesis. So we can conclude that the distribution is not normal, right? So this is the step of doing in SPSS. We just go to analyze, and click on non-parametric test and find one sample KS, right? So this is just an example lah, right? So this is the result of a Kolmogorov-Smirnov. We will look into some significant two tail. This is the value of this is a p-value lah, 0.046. 0.0046 means that it's less than our significant level alpha kan, 0.05. Since the p-value is less than 0.05, so we reject the null hypothesis, we accept alternative hypothesis. So it means that the distribution for this variable is not normal. So this is how we read the statistical result from SPSS. So now, let's look at this one. Another example for Kolmogorov-Smirnov. This is the p-value 0.262, right? Our alpha is 0.05. Since the p-value is more than 0.05, which is 0.262, right? So we're going to accept null hypothesis. We were going to conclude that the distribution is normal, right? Before I proceed further, can you hear me? Right? You can hear me, right? Alright, good. Good. Sebab I tak nampak gambar you bergerak. Can you switch on your webcam so I can see your face? Right. Right. This is another example of Kolmogorov-Smirnov. Right. So, when we want to choose a data analysis techniques, we need to make sure we clear with two criteria of that techniques, right? The purpose of doing that techniques and what are the assumptions required for using that techniques, right? So this is the two main criteria that you need to look before you choose on the data analysis techniques, right? Inference about the population proportion. So for population proportion, we want to compare the proportion observed in a sample equation with standard. This is a non-parametric test, right? So non-parametric test, whether you want to, if you want to compare, you want to see the association between two variable, right? And these two variable are categorical variable, right? Means, let's say you want to know what is the association between gender and smoking. Let's say gender and let's say heart disease condition. Heart disease condition, whether yes or no. Gender is male and female. So you want to know the association. So since we have two category variable, then we can use a Pearson chi-square test. For this example, you only have one proportion, right? One proportion, right? So we want to know, is it true that the proportion of drug addict who contracted AIDS is at least 30%? So we know that the categorical variable is categorical, whether it's yes or no, right? So we're going to use a binomial test. So binomial test, the hypothesis P equal to 0.2, the alternative hypothesis is P is less than 0.2. So this is the illustration lah. So answer this one, at least 30%, 0.3 lah, less than 0.3, right? No, more than 0.3. This one for 30%, right? Okay, this is a step if you want to conduct a binomial test in SPSS, right? So don't worry, I won't ask you the question about how to conduct the test in our assessment, but I will ask you about the result, right? The SPSS result, right? So this is a result present from SPSS. Right. So what you can conclude from the result of test proportion above, based on the data set complex PKNS survey on of public toilet. The aim is to determine whether the majority of public using toilet is dissatisfied. So now you tengok dekat sini, this is basically dia punya result ni nampak macam teruk sikit lah, because kategori ni dia turun ke bawah. Patutnya kategori ni dekat atas ni, and also atas ni, prop observe ada atas, test observe, test prop also semua dekat atas, tapi dia turun ke bawah. I don't know why. Right. So total dekat bawah lah. Group 1 betul dekat atas, group 2 dekat bawah ni. Group 1 is satisfied 22, group 2 not satisfied is equal to 10. So the most of the user are satisfied lah. Right. So we are testing the probability 0.5, right? So we know that 50% are not satisfied lah. 0.032. Right. So this is another example. Like, look at inference about population mean. Right. This is most important part lah. So now here is the flow chart. Right. So the classification of univariate techniques. Right. So we know that we have two type of variable. Qualitative variable and quantitative variable. Qualitative variable, we have nominal and ordinal scale. For quantitative variable, we have interval and ratio scale. If you have a categorical variable, let's say nominal or ordinal scale, so if you want to test for one sample, here is the test, whether you going to use a frequency test, chi-square test, Kolmogorov-Smirnov test, and run test. Run test is another techniques to do a test of different on one group. If you have two or more sample, right? If the sample are independent sample, you can use a chi-square test, Pearson chi-square, Mann-Whitney test, median test, Kolmogorov-Smirnov test, or Kruskal-Wallis ANOVA. Right? So this is when we have independent sample test, independent sample test. If you have a related sample, so you can use a sign test, Wilcoxon test, or McNemar test. Right. If you have a quantitative variable, for one sample, you can use t-test or z-test. If you have more than two sample, if the sample are independent, you can use t-test, z-test, one-way ANOVA. Right? Or if you have a related test, you can use a paired sample t-test. So this is the flow chart, list of analysis that you can apply based on a type of variable and type of sample. Right? Right. So let's look at a test of one mean independence, one sample t-test. To test whether mean of single variable differ from a specific constant value lah. So for example, is the mean beginning salary of our fresh diploma graduate around 1,000 a month? It's a two-tail test. So is it at least 1,000? So this is a one-tail test lah. So we're going to test hypothesis more equal to 1,000 or more than 1,000. Right. The assumption variable should be normally distributed. So if the variable is not normally distributed, you can use non-parametric test. If the variable is normally distributed, you use a parametric test. Right. So this is how we conduct a hypothesis testing. Right. This is the result. Right. Based on this hypothesis testing. Is it true that the mean price of ikan kembung during first week 2004 exceed 8 ringgit? So the null hypothesis mu is equal to 8. The alternative hypothesis mu is more than 8. So the result, if you put in into SPSS, right, the test value should be should put 8, right. The result is going to be like this. So this is the mean and standard deviation. You need to test whether the data is normally distributed or not normally distributed first lah. If the data is not normally distributed, then you cannot use one sample t-test, right? You should use median test or other test lah. Right, this is the result, the t value, the t statistic with degree of freedom. This is the p value. Our p value is less than 0.05, right? When the p value is less than 0.05, we're going to reject null hypothesis, accept alternative hypothesis. So we know that the mean is more than 8 lah. So nampak kat sini pun dia clear cut. So one sample t-test usually we no need to use the t-test, significant test to compare. We can use descriptive statistic to derive to make a conclusion as well, right? So this is how we conclude. So now let's look at independent sample t-test. To compare, the purpose is to compare the mean of variable between two independent group. So is the mean satisfaction score for KLIA different from that of Dubai Airport, right? So we want to know, we want to measure the mean of satisfaction score compared on KLIA Airport and Dubai Airport. So we have two group and one dependent variable, right? Dependent variable should be continuous quantitative. The assumption is the variable should be normally distributed. Means that the continuous variable should be normally distributed lah, right? So this is how we run into SPSS, analyze, compare mean, independent sample t-test. Right, and this is the result, right? First table, SPSS will give us the group statistics, which is include our mean. So you nampak sini type sepatutnya dekat atas, n sepatutnya atas, and then dia terbalik sikit lah. So the mean of supermarket is 9.39. Standard deviation is 0.3478. And this is the result for independent sample t-test, right? And the first two column here is about Levin's test. Levin's test is a test for equality of variance. So when the p-value for equality of variance, nampak tak? Besarkan sikit. Oops. Yep. Nampak tak? So the p-value here is 0.0857, means that it's less than 0.05. Sorry, it's more than 0.05. It means that the variance for each group, for both group, are equal lah. So we're going to read the first row. So nampak nanti sebab sini dia macam I punya table ni, dia bila I paste dekat sini dia tak betul, right? First is the when equality of variance assumed. The second line is for equality variance or not assumed. When the p-value for t statistic is less than 0.05, so that means that there are significant difference between two groups, right? So we're going to skip the example, right? So now let's look at comparing two means. What if you have non-normal distributed data? So when you have non-normal distributed data, you can use a Mann-Whitney test or Kolmogorov-Smirnov-Z test, right? So it's the same purpose. We want to test whether there is a significant difference on mean between two groups, right? So the result which also give the same thing lah. So nanti nampak tak sini dia terbalik, right? So kalau kita tengok dekat sini, the p-value here is 0.0 less than 0.05. Means that it has a significant difference lah. So I just want to touch sikit-sikit saja about the test that we have. Then I assume that you already have experience on using these tests before in STA 210, I think 210, right? 210. So to compare, this is a PAT sample t-test. PAT sample t-test, the purpose is to compare the mean of variable of interest of two dependent group. When you have a two dependent group, means that for example macam entrance survey, before you enroll to this subject, right, you are required to fill in the entrance survey. After, at the end of the semester, you need to fill in exit survey. So these two variable are these two measurement are related sample lah, right? They are dependent group. We are measuring on the same subject. So the test that we're going to use is PAT sample t-test, and then the variable must be normally distributed. It means that bukan bermaksud variable group 1 and group 2 before and after should be normally distributed, but the difference of before and after should be normally distributed. This is the difference of variable must be normally distributed in order to use a PAT sample t-test, right? So the null hypothesis sama juga macam independent sample t-test, but this time we are doing PAT related sample lah, right? Kita balik Yup. So kalau kita tengok dekat sini, the p-value dia akan bagi significant two-tail. This is the p-value and this is the t-value, t-statistic with degree of freedom, and this is the confidence interval, lower confidence interval and upper confidence interval lah, right? So the interpretation are same as Way Anova, independent sample t-test. Right, let's move to the next statistics, which is under the same criteria where we want to measure two dependent sample. For non-parametric tests, we are having a Wilcoxon sign test or sign test or magma test. But magma test is designed for categorical variable lah, right? So the purpose are same. So, but we need to identify the test that we're going to use. Why we use Wilcoxon test instead of PAT sample t-test? Because the difference between two variables is not normal. When the difference between two variables is normal, then you use PAT sample t-test. When it is not normal, use Wilcoxon sign test or sign test lah. So this is the result from Spss. Dia terbalik lah, I don't know why. Right, kat sini you akan nampak dia bagi dua table, first table and second table. But you look into the second table, you akan nampak the p value and the z value, right? So this is going to indicate whether the hypothesis is accepted or rejected, right? When the p value less than 0.05, we're going to reject null hypothesis. So means that there is a significant difference between before and after lah. Right, this is a bivariate analysis. Bivariate analysis sama juga benda yang kita tengok sebelum ni. When you have interval scale or ratio scale, you can use, if you want to find correlation between two variables, right? You can use Pearson R correlation coefficient. If you have ordinal scale, you can use Spearman rank or Kendall tau. If you have nominal scale, you can use a phi coefficient, contingency coefficient. Right, the purpose all are same. We want to find a correlation, right? Okay. Ada soalan tak sebelum setakat ni? Before you move to the one-way ANOVA, where is my one-way ANOVA? So I'm not going to touch in detail about each of the analysis, because this is just want to make sure you know what type of analysis that you want to use if you have this kind of variable. Right. This is an example of a result from Pearson chi-square analysis, Pearson correlation. Pearson product moment correlation. Means that we want to measure the correlation between the two continuous variable, right? And make sure you understand the scale of measurement yang kita ada, and the type of analysis that you should use, right? Okay, one-way ANOVA, one-way analysis of variance. It's the same as independent sample t-test. Right, independent sample t-test, we have two groups, right? Two independent groups. And then we want to measure the difference on mean between two independent groups. But for one-way ANOVA, we have more than two groups, right? So we want to measure the mean, the difference of mean between more than two groups. Means that three or more groups, right? So we want to compare mean of three or more group in the population lah. So we're going to use one-way ANOVA. See, one-way ANOVA, the null hypotheses are same. All the mean are equal. The alternative hypothesis, at least one mean is different. Right, so we want to detect is there any different, right? So we want to use one-way ANOVA. So if we detect the difference on the mean, so we need to do a post-hoc test. Means that we want to identify what are the difference between the group. So we're going to use post-hoc tests such as a least square difference, LSD, Duncan test, Turkey test, Bonferroni test, and many more. Right? You can use, you can choose either one. Right? So this is a one-way ANOVA table. Let's see, kita balik. This is a one-way ANOVA table. So we have a within group and between group, right? So we're going to look into a p-value here. The p-value, if the p-value is less than 0.05, so we're going to reject null hypothesis, which indicate that there is a significant difference, at least one group is significant different lah. So once we already know there is a significant difference, then we need to do a post-hoc test. So this is example of post-hoc test. So now this is just mean, and this is the Duncan test, right? This is another this is a one way to present the post-hoc test lah. So if you look at the significant value, more than 0.05, right? So now Let's look at linear regression. Linear regression, we want to discuss on a simple linear regression and multiple linear regression. Right, the purpose of linear regression is to analyze the relationship between one variable, which is dependent variable, and another set independent variable. Right, so we want to measure the relationship. So, but for linear regression, we are not stopping at measuring the relationship, but we are more on beyond than that. Means that we want to do some prediction, right? If you want to do a prediction between dependent variable and independent variables, and then the linear regression, it should be very is a suitable method. But if you just want to find the relationship, right, you should go for correlation or association techniques lah. Right, this is the flow chart, right? Relationship between two or more variables. Right, if you have two variables, two category continuous variable, then you can use a correlation test. So in correlation test, you can have a Pearson product moment correlation test, Spearman rank test, Kendall tau, phi, Kramer v, and so on. This is for nominal scale. So it measures the strength or and direction of linear relationship between pair of random variables. So if you want to measure association between two variables, two categorical variable, right? Categorical variable. This one akan letak sini, categorical. Two categorical variable. So you can use a chi-square test of association, independence, and homogeneity lah. So both are qualitative or categorical variable. Right, now for regression, so you have a lot of regression techniques. We are looking into a linear regression. So basically in this world we have a lot of regression, such as a logistic regression, linear regression, log by log regression, Weibull regression, Cox proportional regression, Poisson regression, and many more, negative binomial, and so on. Right, so it based on the distribution, right? So in regression, for linear regression, we are discussing on linear regression. For it should have a one quantitative dependent variable and one quantitative independent variable, right? Or more than one independent variable. If the dependent variable is qualitative, then use logistic, but it's not necessary. But most of the time when you have a categorical or binary data, binary categorical data, then you can use logistic regression lah, right? But you need to fulfill all the assumption. Okay, for linear regression, simple linear regression is to predict one quantitative independent variable based on one quantitative independent variable, right? For multiple linear regression, to predict one quantitative dependent variable from several independent variable. So this is the main criteria lah. Right, for logistic regression, no need to touch yet, but to predict one binary qualitative dependent variable, right? So this is a formula for linear regression, simple linear regression. Right, the assumption for simple linear regression, the error term are independent, right? Identically normal distributed with mean equal to 0 and constant variance sigma squared. There is a straight line linear relationship between mean and y value. This is a linearity assumption. So you need to know the dependent variable should be linear in terms of, if you want to use linear regression, you need to make sure the dependent variable is linear lah. And of course equality of variance lah, right? So this is how we use in Spss, right? Now I just want to look into the result given by SPSS. So this is the model one, that we input into SPSS. So we are inputting skin as dependent variable and ozone as independent variable. You look at this one, R means that the coefficient of determination. Sorry, coefficient of determination is R squared, right? R is the coefficient value, the relationship value. Means that if you are measure the Pearson product moment correlation, so this is the Pearson product moment correlation coefficient, right? So this is the same value as a Pearson product moment correlation lah. So 0.9 means indicate that we have a strong positive correlation. R squared is a coefficient of determination. Coefficient of determination means that R squared. It explains how many percent variation in dependent variable, right? Okay, so I hope you understand the result, how to interpret the result. So R means that the correlation coefficient. R squared means that the coefficient of determination, which is R squared, right? So this is the one-way ANOVA table presented in linear regression, right? If the p-value for one-way ANOVA table is less than 0.05, then we can say that the model is valid for prediction, right? So then we're going to look into the coefficient table. If you are using SPSS, the coefficient table will give you the value of dia nampak sini dia terbalik sepatutnya dekat atas kan, dia macam mana dia turun bawah, I'm not sure. The constant should be upstairs, dekat atas ni. Dekat bawah ni ozone depletion rate. So this is the beta, this is a standard error, this is a beta coefficient, standardized beta coefficient. We're not going to look on this because we are considering the intercept kan. Bila you considering the intercept, you're going to use unstandardized coefficient. So the p-value is less than 0.05 for our independent variable, means that the variable is very important towards cancer, right? So this is the 1.406 is the beta coefficient for intercept, beta naught, and 0.620 is our beta 1, right? Beta coefficient for independent variable. So this is going to be your equation, right? I think that's all. For multiple linear regression also same result. They will give you a same result, right? So the way you interpret also same. So I don't think you should have any problem on interpreting and understanding the result of the analysis. But the point is you need to understand this flow chart. Where is my flow chart again? This flow chart, when to use a simple linear regression or multiple linear regression, when to use a Pearson chi-squared, when to use a Pearson product moment correlation. Another flow chart is you can screenshot this one first. The second flow chart yang I bagi tadi, mana dia? This one. No, not this one. Yeah, this one. So this is another important flowchart that you need to understand. When you have this kind of data, what kind of test you should use, and what are the purpose of the tests that you're going to use, right? So I think that's all for our syllabus as STA 220, right? So in a textbook, you refer to Ranjit Kumar and Umar Sekaran, and if can, you can download Salkin textbooks. Salkin textbooks. At the end of the chapter dalam buku Salkin tu, dia ada tunjuk macam mana nak buat proposal, how to write a proposal. Please read that chapter carefully, right? Because your proposal due date is just a few weeks incoming. Dalam 15 hari bulan you kena hantar dah, right? So you ada lagi 1 minggu, 2 minggu saja. You ada 1 minggu lagi lah nak habis dah kan. So make sure you habiskan cepat. Tengok the procedure on the textbooks, right? So before we end our session, do you have any questions so far?